And in the beginning, I thought, speaker, a microphone, a chip, a little bit of plastic, and a battery. How difficult can this be? But it is, yeah. There's a lot of nitty gritty detail in tuning this. So that's we are supporting manufacturers in doing that.
All right. Good afternoon, everybody. Dave Lindbergh in Hong Kong with a new episode of THD Podcast. Thanks for joining us. Please like, subscribe, all that good stuff. Today we have a company from the Netherlands called Absolute Audio Labs, and we're going to find out about their algorithm for signal processing. I think it's like background noise reduction, voice enhancement, this kind of stuff. So it's very in demand nowadays. But without delay, let's give a shout out to our sponsor, the ALTI Association. They're going to be at Expona in the Chicago area and then at the high-end show in Vienna coming up in the next few months. So please go say hi to Barry and the crew there. And also, Audio Express magazine, please subscribe to that good publication supporting the audio manufacturing industry. There's quite a few articles actually on Absolute Audio Labs in there and their partnerships with Renaissance and different activities and briefings on their technology if you find this interesting. So please go have a look there. But without delay, let's get into what we want to talk about today. We've got Simon in Japan. Good afternoon, Simon.
Hey, Dave. Hi, Mark.
All right. And Mark Kaal, the Director of Business Development and Innovation at Absolute Audio Labs. Thanks for coming back, Mark.
Thank you. Thanks for having me. It's always a pleasure. I've been a big follower of the podcast, and of course, I saw Adri from PYOUR from Renaissance appearing a few weeks ago. So I felt that, and now it should be my turn to get the spotlight.
Okay, yeah, let's jump into a presentation to update people on what you guys are working on.
All right, yeah. So just give you a quick overview of what we've been doing in time. Absolute Audio Labs is a company that originally started out in music enhancement for hearing impaired with my co-founder Arnoud. He is always been an active musician, damaged his hearing while performing with drums on stage, and founded a company and partnered with a French headphone manufacturer called Parrot. Mm-hmm. So that was the first version of our PYOUR audio platform. Then at that time, I met him at CES. I was leading a team that was a spin-off of one of the Amsterdam universities on speech intelligibility and noise suppression improvement. We partnered. We returned back to CES as the new and improved Absolute Audio Labs and launched our second generation, which was then based on Qualcomm. Then 2 years ago, we launched our third generation of PYOUR Audio, which is now more focused on becoming more chip agnostic. And at that time, we announced our global launch partner being Renaissance. Now later this year, we're now at edition number 4. So the fourth generation. And the fourth generation is all about merging in more neural network based applications in the audio chain for all related processes that you need to run inside a hearing aid. So not just noise improvement, speech intelligibility improvement, but also room reverberation, scene detection, and other supporting algorithms. So that's what we've been doing. With the chip agnostic part also comes that we need to demonstrate, or we've ventured into additional partnerships, and they go across 2 axes. On the one axis, we've expanded the number of chip manufacturers that we work on, and on the other axis, we've opened up PYOUR Audio for other software developers to bring their plugins into the platform as an add-on option. So they're typically experts in their field of business, and we make sure that we keep their solutions compliant with the number of chipsets and in the full hearing aid system solution. So that's in a nutshell. If I go here, what that means, this is a little bit the AL ecosystem as it is shaping up today. We've been expanding our chip partners. So we've ventured into partnerships with NXP and with Onsemi, as where originally we always were working on the Qualcomm platform. So that's the set. We've added software partners. Most in the news has been our partnership with ASIP. We've added Bphonics, which is a Dutch academic startup that focuses on beamforming, inspired by how bees do sound localization. We have a partnership with Mary out of Taiwan. And there's another one, Golden Hearing, which is also a Dutch academic startup focusing on music enhancement. And in the collaboration with Mary, we also partner with ITRI, which is a Taiwan State Institute for Applied Research. So, and then on the component side, we generally work very close together with Celtec, also as our distributor for AL, especially focusing on the Asian markets. Of course, on the component side, acoustic components, we always had a very strong relationship with Knowles, and through Celtec, we're now doing also a little bit. With Sonian, and through Celtec, we're doing a little bit more with Knowles now. And on the battery side, we always looked at Varta, because what's important for AL, and this also relates to our partnership with Renesas, is that we want to bring new types of chips into the hearing aid supply chain. And the types of chips that we're particularly interested in are generic audio socks. And we want to make sure that they are suitable to power a hearing aid. And with Renesas, we achieved that. And at the same time, we want to make sure that hearing aid manufacturers have a choice of components that they can use. So that means that we also have to want to work with the chip manufacturers that historically always have been very big in the hearing aid market, like NXP and Onsemi. So that's a little bit the model.
Curiosity, Mark. Like, I think that's the first time I've seen a battery company as a partner. Like, how much work can be done from the battery side to complement what you guys are doing? Is there some come up that they can do to improve?
It's more on the exchange of information and roadmap alignment. It's less of technical integration. The pitch that we want to make for a sock-based hearing aid is what we can do on the sock, or how far we can go in optimization together with our chip partner. But of course, the more battery budget we get, the easier our task becomes. So therefore, we are very eager to learn what is the latest and greatest, and to try to design that into reference designs, and see if we can squeeze a few hours more of battery life out of a new battery compared to a previous version.
Right. Okay. Interesting.
When you talk about integration with different chip platforms, so the underlying theory algorithm, let's say, is mathematical in a sense. So when you have to integrate it onto a chip platform, what's involved with that? Is there it's not specifically their hardware, it'd be more their development environment, something like that?
Yeah, so what we try to do is we create our own layer over the various chip platforms. So we work with the design tools of the chip manufacturer, but we also have designed our own tool, what we call the PYOUR audio development platform. That's also where we integrate our software partners first. So that's PC based, and it's like a 3-layered model. So when you design new algorithms, typically you do that as a floating point, so you can use more mathematics and easier, but that's taking up too much energy, and it's not always supported by the chip. So therefore you have to convert that to a fixed point solution. And once you have that, you need to convert that, to port that to the target platform. So that is what we do with our own tools. And then to convert that to the target platform, you're also using the tool chain of the manufacturer. But the audio chain that we support is generally working. The basic principles are always the same. So the way it's deployed as a general rule is similar on every platform. And then you, of course, have the differences that are related also to the features that the platform has, and they're not always the same.
Okay, next point. And I mentioned just on the last slide, you were talking about, I think it was AI scene detection.
Yep.
What does that mean?
That basically means that you run a lot. You run your own neural network that decides on where are you
Oh.
acoustically.
Mm.
So what is the kind of environment that you're in? So therefore, what is the hearing aid supposed to do to give you the best, to optimize the result for the environment that you're in? If you're in silence, the device will behave differently as when you're in a noisy restaurant. And that is something as simple of switching on or off directionality based on the detected scene, or but it can also be other. When you're in this, and it gets more complex. When you're in a bar, there's live music, and you want to order a beer.
Mm-hmm.
So it's sometimes it's also when it gets too complicated, we switch to noise estimation rather than scene detection.
Okay.
Because we have multiple things that we want to optimize at the same time.
Okay, and there was a couple of other. I was curious because there's a couple of other items listed as AI. You mentioned it's a neural network approach. Your core element is not. It's a kind of a fixed algorithm.
It's a suite.
Yeah.
It's really a suite. So the core is really the hearing aid. You go down to the core of what a hearing aid or a hearing enhancement solution needs to do. You basically need to do two things. You need to provide the user with an increase SNR in noise for the purpose of improving speech intelligibility. Our suite achieves that by applying directionality and noise suppression. Currently, we have our own signal enhancement based noise suppression, and with AZIP, we're using an AI-based noise suppression. But in the system, they have the same role. And then the second thing you have to solve is you need to provide gain to correct for the hearing profile, and that introduces, typically based on also proximity of speaker and microphone, that introduces acoustic feedback. You have to apply compression, so those things also need to be taken care of. And then the rest of your system is really to make sure it all runs, that you deal with artifacts, or that you cater for specific environments like wind. All kinds of stuff to optimize, or to make sure you cannot exceed critical values, or all of that. But in the core, the two things you have to do is provide good speech intelligibility, so you lift the hearing impaired user up to the level of the normal hearing user, and you need to provide amplification and deal with the consequences of that.
Okay. And when somebody comes to implement one of these systems, how much of a constraint do they have around their acoustics, their audio speaker performance and microphone performance?
Generally speaking, our algorithms will run in the transparency chain. So it's a little bit of a design choice. If you want to have that running while you're doing streaming, or while you're having a phone call, etc. In principle, there are no constraints, but of course, when you merge A and C into our solution, then you have to design for that, and that will have some impact on how you organize your hardware.
Okay, and then part of the solution package, does it include support for their acoustic design? It must be
Yes.
fairly fundamental to getting the system to work, is what I'm getting at.
Yes, yeah. No, when I ventured out in the hearing aid space a little while ago, and in the beginning I thought, speaker, a microphone, a chip, a little bit of plastic, and a battery. How difficult can this be? But it is, there's a lot of nitty gritty detail in tuning this, so we are supporting manufacturers in doing that.
Yep. Okay. Because hearing aids often have a speaker in the rear and then a small tube channeling into ear canal. They must have some.
Yeah, there's two dominant form factors in at least the hearing aids that cater to the hearing care market. So the audiologist fitted hearing aids. There is the what we call the receiver in canal. I know you had a discussion with Adri on why this hearing industry calls a speaker a receiver. Um, but so that is, definitely in markets like Europe, North America, it's 70% of units sold. They all have the speaker in the ear canal, and the rest of the electronics is behind the ear. And then the other 25% is behind the ear, what we call them. So that means that all the electronics are behind the ear, and you have a thin tube, like you were describing, going into the ear canal. In markets like China, you see some different product mix. So this model is more popular in China, and the RIC model is less popular. And then you have all kinds of other form factors that basically means that you're going deeper in the ear canal.
Okay.
That sounds very appealing. So definitely for first-time users, they will be very appealed to invisibility. But it comes with a caveat that you put something in your ear canal that closes it off, and that might give some comfort issues. And generally, that's why a lot of folks prefer to have these RIC hearing aids and then an open fit, so that they keep their acoustic awareness and see that as the most comfortable way of wearing a hearing aid.
Yeah, and I read that your software actually helps enable miniaturization. Is that accurate? Like, I read online about this.
Yeah, I mean it's all about. Well, there's two things that we do to help miniaturization. One is AL is not a pure software company. We do have a small hardware proto lab.
Okay.
We do have folks that have a strong design background in the hearing aid market. They've done these small in-canal products, so they're very, very familiar with what needs to be done to miniaturize. But the essence is what we do from the software side is power. We allow a smaller battery, so therefore the form factor is in line with what you can do when you use a purely hearing aid supply chain components. So we merge in a Renesas chip in a reference design. It's a bigger chip. It is running on a 3.7 voltage, as where hearing aid chips run on 1 volt. Then you have the support components. So all of that means that your BOM or the dimensions of your BOM purely from the component size is bigger than with a traditional build. At the same time, if you want to make that a product and you want to market that, you need to adhere to the design constraints of the hearing aid market. So there's rules of thumb for your maximum thickness, length, etc. And if you don't adhere to that, manufacturers will not design in that technology. So that is where it all needs to come together. And in the project with Renesas, there was another partner involved, also a Dutch company called Doppel, and they're very specialized in miniaturizing the PCBA. So that's an important element as well.
Okay, interesting. So people could actually come to you to get perhaps a whole design, software and hardware laid out for them if they wanted.
Yeah. I mean, we deal with manufacturers in all kinds of sizes and flavors, and they have different R&D capabilities. So depending on what their capability is, we can add partners, or we can add our own support. There's quite a few that are now designing in with our RIC reference design. So the mechanical design is from AEL. We're happy to do so. But we want to stay focused on where we're good at, which is kind of the middleware part. So organizing the system and make sure that it deploys on the chips that we support, as well as designing and maintaining a very competitive algorithm suite. And then merging in other technologies, from other partners, as we see that, for the mid-size and smaller manufacturers, that is the way to go on innovation. You have a more robust supply chain, you have more to choose from, and you have innovation on a continuous base, because smaller players are now, organized in a way that they can focus on what they're good at and don't have to bother too much about the other stuff.
Okay.
Your customers are building hearing aids, and they come out looking for this technological solution, essentially. How far up the chain do you have to go? Because it sounds like pretty far if you develop Do they build firmware around this? It's a library function that just works out of the box and they do whatever they like on the rest of the system?
If it's a purely a hearing aid player, then our system essentially will function as the operating system.
Mm.
So that is the central part, and then you put the other bells and whistles on there. If it is more like a TWS product where you have multiple things, then that's a whole different collaboration. That's a whole different game plan, because that means that we're generally appearing in a transparency chain, as we do a little bit into streaming and we do a little bit on HFP with phone calls. But it's primarily correcting for the personalized audio.
Mm. So for the hearing aid customers, then the reference design is essentially what they implement with
Yeah,
maybe some minor
yeah,
customization.
yeah. Generally, yes, that means that they do tuning and configure, but the configuration they essentially will leave it as is most of the time. Sometimes they have some of their own algorithms, and we'll merge that into a dedicated audio chain, and they will work with that.
Okay. It just sounds a bit like okay, the guts of the technology of a hearing aid, it comes from you guys. And then what do those hearing aid manufacturers offer after that? I mean, do they have a region market that they serve, or they have some other differentiation from their competitors?
Yeah, I mean, there's differentiation in the mechanical design. There's differentiation in the software, the peripheral software that they build around it. So how test your hearing test. How do you fit the instrument to the parametric control? All that environment is up to them. The end user app, that's we support it with the Bluetooth SDK, but we don't do the GUI. So all of that is theirs. Of course, you need to bring it to the market, medical device or certification,
Right.
all of that.
Right.
And they cater to, most of our customers cater to, there are a lot in Asia, and they cater to the local markets, but they also export. And in export, when they export to Europe or to North America, it is primarily in all kinds direct to consumer models. It's less in the hearing care market. It's not in those territories. That space is more closed. It's dominated by 5 manufacturers, and it's quite difficult for the mid-size and smaller hearing aid manufacturers to get access to the hearing care markets in
Yeah.
Europe and North America.
So those big players, they have their own proprietary in-house methodologies that they don't tell anybody about. And then the rest of the market, anybody smaller needs to go and find that solution, which is you guys.
That is mostly true. You'll see some that do some internal firmware development, but not a lot.
Mm. Some being the
And
bigger players, you mean, or the
no, the of the mid-size and smaller
I see,
ones.
yeah,
But
yeah.
so most will rely on an algorithm provider, and that's in the hearing aid space. There are not a lot because it's quite complex. So when you see TWS and personalization for hearing, you see quite a lot of players. But
Mm.
when it gets to hearing aids, that market is considerably thinner. What we're going to see in the next few years is that also the big players are seeing that, because they're also doing, at least most of them, 4 of the 5, custom chip development.
Okay.
And that starts to come to an end, because with every next generation, you want to work on a different node size, and the investments are
Mm.
going to be so big that even at their scale, they can no longer afford that. So that means that our chip partners, are also in the market to see if they can get a bigger piece of the pie in providing a more complete chip
Mm.
to all the players. So what the good news there is for the mid-size and smaller players, that they're getting more a leveraged playing field in the component side.
And that the regulatory side of it, getting certificates for this product, how much of that, I know nothing about it. To what extent does it involve the actual capability of the algorithms, let's say? Is it focused on that so much, or is it focused on other safety and these type of
It's
things?
it's primarily safety driven.
Yeah.
Yeah, so the whole regulatory system is you have to demonstrate, at least when I say you, it's our customer, so it's the manufacturer that have to certify the device. They have to demonstrate clinically that it works. So that and then it depends a little bit on for which category you certify, what you have to demonstrate. But the bulk of the certification is around safety.
I see. Okay. And the it works threshold is perhaps not that high, then is that the implication?
Yeah, the fact that your product is certified doesn't tell you of whether it's a good hearing aid.
Hmm.
It will tell you that electronically and mechanically, it's not a bad hearing aid.
Okay. Okay.
Sounds like a bit of a mafia to get into the medical grade hearing aids.
Sorry?
I said it sounds like a bit of a mafia controlled environment with the classic hearing aids.
I wouldn't go that far, but it is the market. These five players are quite dominant, and they do have a quite ingenious system that is, for hidden entrance barriers.
Yeah.
So the hearing aid market has two large barriers to entry. One is the access to distribution. The other is access to technology. We're playing on the second barrier.
Okay.
But like I said, the hearing care market in North America and Europe, it's still very difficult to access for a new player, if not almost impossible.
Right.
Interesting.
Okay.
And in terms of performance of this type of device, it's a subjective thing essentially, and you always want to try and quantify it so you can say, here's the performance of my product compared to another one. How do you go about that for this type of thing? Because it seems to me to be too a personal experience that tells you if it works or not, how well it works.
Always, you'll see that the way it's tuned, etc., will be more appealing one for the other. However, you can objectivize the performance, especially around speech intelligibility performance, and we've done that. So the way to go is that you create a setup. You have three form factor-wise identical hearing aids. And you run it with a series of with a number of hearing impaired patients. We've done that. We've done that together with an academic medical center, and then people will hear through a headphone, but they will listen via the test setup to the microphones of the hearing aid and the speaker of the hearing aid, and then you have sentences and noise, and that means, and then the test is set up. You're always pushing to you can barely hear it, and then you hear a sentence, and then the person taking the test has to reproduce the sentence. What did you hear? And then one of the researchers will judge right or wrong, and the other will manage a list of which device when to offer. And that kind of test, we've done that. We've done that with at that time, so this was a test we did 2-3 years ago with flagship models of the big five, these big five companies.
Yeah.
In this case, Oticon and Resound. That test demonstrated that AEL was at par with Oticon, which we were very proud of because they were known for being the best in the market on that topic. We were significantly better than Resound. Resound, in the meantime, has released a new generation, so they have improved definitely on this part. They've made it a huge marketing item that their score is so good, and that the performance increase was so good from one generation to another. But that's a marketing thing. If you start low enough, you'll get the improvement.
Yeah. I see. So it's actually a real human evaluation test. That's quite a well-established thing, then, is it? That
it is, and now there's new test methodologies popping up that try to automate that. But most of the time it's still, and doing that with these kinds of panels, it takes time. It's quite costly, and also when you do it with an academic medical center, that adds to stuff because they need to adhere to their own compliance and medical ethics and etc. So you know it's not a test you'll do every day.
If you don't mind, just linger on a bit. So you have to go out and recruit people with a certain level of hearing loss to be
Yeah, that's in your
evaluated.
inclusion criteria in the test. So you create a test protocol, or the researchers do that, and they write up,
Okay.
you know, who should participate, what profile, so
Mhm.
that ideally you don't want to have too many outlier kind of audiograms, so that your group is a little bit consistent. So you know that you have the ability that your conclusions, the more you have, and the larger your group is, then you know you do your statistical power so that you can support your conclusions with you know a degree of certainty, let's say 90%, etc.
And as I say, let's contrast it with consumer A and C headphones. We might say, brand A is very good. That one's the best, and brand B is very close, but they're not quite as good. But both brand A and B have a performance level that exceeds a kind of a threshold of what's good enough. So you go for the
Yep.
cheaper one, let's say. Do you have that kind of a situation with hearing aids, or is it still the case that any incremental gain is of huge benefit to the users, let's say?
No, you should have a situation where it's good enough.
Mhm.
Um, you know, there is a US consumer website, Hearing Tracker. They do these kinds of reviews. That this is part of their review methodology. Um, but as a general rule of thumb, a hearing impaired person, averaging everything out, so it's a little bit tricky to make that statement. You
Yeah.
need about 560 Bs in added SNR improvement compared to the normal hearing. That means that if you're in a noisy, let's say the famous cocktail party, then a normal
Yep.
hearing person can pick up sound, let's say 560 Bs below the environmental noise level, and the hearing impaired person cannot. So after correction for somebody's audiogram, you need to find those 560 Bs. If you do that, you have a good hearing aid
Mm.
Okay.
because that means that you can restore the level of hearing to the level of the normal hearing. If you don't do that, it's not a good hearing aid. You can still have great wireless features, you can still have all kinds of bells and whistles, but it doesn't function, it doesn't deliver on the core of what it should do.
Right. It's like a car with a nice paint job. Doesn't do you much good if it doesn't drive.
Hey, one more thing. So, for someone who doesn't have a diagnosis of hearing impairment, let's say hearing's fine, can a device like this offer something like Superman hearing in noisy environments? Does it still have application?
Yes, well, Superman maybe is a little bit too
But,
exaggerated claim, but you will improve. You give an SNR improvement also for normal hearing if you're in the environment, that the noise level. If you're in silence, no. But if you're in a noisy bar and you want to have a conversation, then yes, that will help you. That should be able to help you. The impact is not as big as for a hearing impaired person,
Yeah.
but it may be that if it's truly noisy, then you can have a conversation at a distance of a meter, maybe meter and a half, with supported technology, as where otherwise you would have to go to half a meter. Now, depending on the type of conversation and the person you have the conversation with, maybe you want to have that half a meter, so you have an excuse. But technology would allow you to increase that distance.
When me and Dave are out picking up chicks at a bar, we don't want to be leaning in the whole time. We want to be able to stay back and cool and calm, but
I know
still
that's
communicate.
everybody will have their own strategy there.
That's
Uh,
it from me.
okay. Anything else to share with us today, more?
No, I think I wanted to share that, we're expanding we've expanded, I know Arnold has been on the show 2 years ago, and, of course, Adri van Meijer from Renaissance was here. I think we're in a good spot with Renaissance, and we're now rolling out that solution we built together with them. We're also rolling out the solutions we built with NXP and Onsemi. So we're seeing all these kits going to the market as we speak, and I think the strategy to open it up for other software developers, especially also, like I said, with AZIP, we're most advanced. I think AAL has evolved in a multi-platform supporter, and we're now helping to drive an innovation and a supply chain network. And I think for us, it's a good spot to be in. So I think we're comfortable, and we're happy to move forward with the stuff that we've been developing and doing, and we see some good results in the market.
Okay. Is there any events upcoming that you guys are going to be attending? I see with this Taiwan connection, will you guys be at Computex perhaps in the summer?
That's a good question. I mean, in our partnership with Mary, we do visit Taiwan regularly. It's still a discussion. It might be. We're definitely going to be at UHA, which is the largest trade show in the hearing aid space in October in Germany.
Yeah.
AAA is coming up. It's a big hearing aid show in the US.
Yeah.
So if we're not there, some of our partners will be there demonstrating AEL like we did with CES, where AZIP, Renesas, Celtec were demonstrating AEL, but then incorporate to their demo kits. So if it's not us in person, it will be our technology and with our partners. So that's it's probably also BIAC in Beijing audiology show end of May. All these events, AEL demos will be there. So check it out.
Okay. All right. So yeah, thanks everybody for watching. Thanks Mark for joining us, and we'll see everybody on the next episode. Bye bye for now.
Thank you. Thanks for having me.